Hello again, everyone. Today we're going to talk about 8.2 multiply and factor polynomials. Remember from before when we were talking about polynomials, those are algebraic expressions. And we're going to talk about multiplying them and factoring them. Now multiplying can also be called distributing, and most of us are pretty good at distributing, so we're going to just spend just a little bit of time of reviewing how to distribute. So for instance, if I have an example like 2 and then parentheses x minus 1. Now the way you say that would be 2 times the quantity of x minus 1. Distributing, as we should already know, just simply means you're going to multiply whatever this is on the outside to everything on the inside. So we just end up with 2x minus 2. Fairly simple. It can get a little more complex. For instance, if you had 4g squared times the quantity of g to the third minus 2g plus 3. If I asked you to multiply that, you would again distribute to all parts. Can't forget that. Now you have to remember your rules of exponents here. So when I multiply 4g squared times 4g to the third, let's remember this is what it looks like. And the rules of exponents say that you add those exponents together, so I get 4g to the fifth. So don't let that confuse you. Even though you're multiplying, you are adding your exponents. So when I multiply 4g squared times this, it would say 4g squared times 2g. So I'm going to multiply 4 times 2, 8. G squared, and g to the first is g to the third. And lastly, when I multiply it to here, it is 4g squared times 3, which would be 12g squared. Quick review, what type of polynomial is that? The trinomial. What degree? Fifth degree. Let's try another one. Let's see if that all made sense. Let's say I had negative 3x times x squared plus 4 minus 2x times x to the third minus 6. Okay, so as I look at this, we have two opportunities to distribute. Here's one of them. So I'm going to distribute negative 3 to the x squared. So remember, you're going to add your exponents. That's x to the first. So it's negative 3x to the third. Then multiply here. So it's negative 3 and 4 is 12x. Now over here, remember, you have to not just look at this, but you have to look at this also. This is not just a 2x. It's actually a negative 2x that you're going to distribute. So it's negative 2x. Now remember, add the exponents to the fourth. And then distribute again. Negative 2x times negative 6 is positive 12x. Now one of the things that you have to always do is look at what you're left with and see if there's anything you can simplify. So as I look at this, I notice I have some like terms. Here's a like term, and here's a like term. And what is negative 12x plus 12x? Well, it's nothing. They cancel out. That's nice. So I'm left with, and I'm going to put this in numeric order, highest exponent first, negative 2x to the fourth minus 3x to the third. And once again, quick little bonus here for you. And what type of polynomial is that? It's a binomial. There's two terms, and it's a fourth degree. Now, hopefully that made sense. Hopefully that was a little bit of review. Let's move on to factoring, though. Now, factoring is the exact opposite of what we just did. And we're going to talk about first factoring monomials. Now, if you remember, a monomial is a one-term polynomial. So we're going to be factoring one term out of a polynomial. So for instance, if I have 14x plus 21. So what I'm going to do is I'm going to look at each term and decide what common factor do they share. So remember, a factor is a common factor would be like a common number that would divide into both of these. Well, the largest common factor that 14 and 21 both have is 7. So I'm going to factor out or pull out a 7. And when I pull out a 7, 7 times what is 14x? Well, 7 times 2x. And then 7 times what would be 21? Well, it would be 3. And so I factored out a 7. And there you go. I'm done. Now, what's an easy way to check? Well, an easy way to check is if you wanted to, you could distribute it back. If I distribute it back, I get 14x plus 21. Okay, so this idea of factoring a monomial is you are looking for common factors. So let's try another easy one here. 6x squared plus 9. So what common factor does the 6 and 9 have? Now again, when I say common factor, I mean the largest common factor. Well, 3. 3 will divide into both of them. So if I take out a 3, I'll put it here, parentheses. So you can think of it in two ways. 3 times what will give me 6x squared, or 3 divides into 6 2 times. 3 divides into 9 3 times. And I'm done. There you go. Now, it's not always quite that easy. Plus, we can include variables also. So let's do one with variables. X to the 4th minus 3x squared plus 5x. Now this time, if you look at the numbers, remember there's that imaginary 1 sitting there. 1, 3, and 5. They have no common factor outside of 1, so we can't factor any numbers out. But if you notice, each term has at least one x in it. So I'm going to actually take one x out of all of them. Okay? So if I take an x out of all of them, what do I have left? Well, if I take an x away from x to the 4th, I'll have 3 of them left. If I take an x away from negative 3x squared, I'll have only 1x left. If I take an x away from 5x, I don't have any x's left, and I just have a 5. And that's it. Okay, I just factored out a variable. Now, it gets a little challenging when you can actually factor both numbers and variables. So for instance, okay, so there's a third degree trinomial. So let's just start with the numbers. What is the biggest number or biggest common factor between 9, 6, and 12? Or think of it like, what's the largest number that will divide into all three of them? Well, that's 3. What about the variables? They all have at least how many variables? Well, they all have at least one x. This one has 3, this has 2, this has 1. So they all have at least one x. So I'm going to take an x out also. So let's figure out what's left over. 3 divides into 9 3 times. If I take 1x from 3, that means I have 2 left over. 3 goes into 6 twice. If I take 1x away from 2, there's 1 left. And 3 goes into 12 4 times. If I take 1x away from 1x, I don't have any x's left. And there you go. I'm done. So let's just try one last one. See if we get it. So 40x to the 5th minus 32x to the 4th plus 8x to the 3rd. Alright, so let's look at our numbers. What is the largest number that will divide into all three of these? Well, it's 8, so I'll put an 8 here. And then let's talk variables. They all have at least how many x's? Well, they all have at least 3 of them. So I'll put x to the 3rd. And what do I have left? 8 divides into 40 5 times. If I take 3 x's away from 5, I have x squared. 8 divides into negative 32, negative 4 times. If I take 3x's away from 4, I have 1 left over. And then finally, 8 divides into 8 one time. And if I take 3x's, or x to the third, away from x to the third, no x's left. And that's it. That's all there is to factoring monomials. Now, there are different types of factoring. We'll talk about those eventually. But that's the first step. So hopefully that made sense. If you have any questions, make sure you come to class tomorrow with those questions. Also, if you're looking for this outline set of notes, just go on the shared file. It'll be sitting there for you. All right? Have a good night.